regăsit la PoliTech! Sunt Alexandra Marian și începem împreună o nouă ediție. În cadrul unui eveniment spectaculos desfășurat în inima Texasului, la Austin, miliardarul Elon Musk a dezvăluit în urmă cu câteva zile proiectul Terafab, o megafabrică de semiconductori care promite să producă mai multă putere de calcul decât toți ceilalți producători globali la un loc. Investiția a fost calculată la aproximativ 25 de miliarde de dolari și va fi făcută în Texas. Trecerea la faza de producție este estimată pentru prima jumătate a anului viitor și ar urma să susțină nevoia de semiconductori pentru SpaceX și Tesla.
In order to understand the universe, you must explore the universe. And that's the motivation to accelerate humanity's future in understanding the universe and extending the light of consciousness to the stars.
Proiectul Terafab reprezintă vârful de lance al integrării visate de Elon Musk, fiind o colaborare fără precedent între companiile sale emblematice, Tesla, SpaceX și XAI, cu o investiție estimată între 20 și 25 de miliarde de dolari. Această facilitate mamut, ce se va extinde pe milioane de metri pătrați în campusul Giga Texas din Austin, are ca obiectiv atingerea unei capacități anuale de calcul de 1 terawatt. Această cifră ar urma să depășească de peste 50 de ori producția actuală combinată a marilor giganți din industria chipurilor, transformând Terafab în inima pulsând a noii ere a inteligenței artificiale.
To give you a sense of what we're talking about, the current output of AI compute is roughly 20 gigawatts per year. So if you add up all the fabs on Earth combined, they're only about 2% of what we need for the terawatt project, or Terafab project. And we're starting off with an advanced technology fab here in Austin. So in the advanced technology fab, we will have all of the equipment necessary to make a chip of any kind, logical memory, and we will also have all of the equipment necessary to make the lithography masks. So in a single building, we can create a lithography mask, make the chip, test the chip, make another mask, and have an incredibly fast recursive loop for improving the chip design. So, and we're not just going to do conventional compute in this. I think there's some very interesting new physics that is potentially, that actually I'm confident will work. It's just a question of when. So this is we're really going to push the limit of physics in compute. And we're going to try a bunch of wild and crazy things, which you can do if you've got that fast iteration loop. So broadly speaking, we expect to make two kinds of chips. One will be optimized for edge and inference. So that'll be used primarily in Optimus and in the cars. But especially in Optimus, because I expect the robots, humanoid robots, to be made 10 to 100 times more than the volume of cars. So, you know, if vehicle production on Earth is about 100 million vehicles a year, and I expect humanoid robot production to be somewhere between 1 billion and 10 billion units a year. And then we need a high-power chip that is designed for space, that takes into account the more difficult environment in space, where you've got high power, you've got high energy ions, photons, you've got electron buildup. It's a hostile environment in space. So you want to design the chip you want to optimize it for space. For the space compute, my guess is that is the vast majority of the compute, because you're power constrained on Earth. That's why I think it's probably 100 to 200 gigawatts a year of terrestrial chips, and probably on the order of a terawatt of chips in space.
Această primă unitate pilot este programată să devină parțial operațională până la finalul acestui an, având sarcina critică de a produce primele loturi de serie mică ale chipului AI-5. Aceste componente timpurii sunt vitale pentru testarea noilor sisteme de echilibru și navigație ale roboților umanoizi, oferind inginerilor datele necesare pentru a rafina designul înainte de producția la scară largă. Trecerea la faza de producție de volum este estimată pentru prima jumătate a anului viitor, moment în care Terafab ar trebui să atingă o cadență de aproximativ 100.000 de unități de procesare pe lună. Acesta va fi punctul de cotitură în care dependența de furnizorii externi, precum giganții din Taiwan sau Coreea de Sud, va începe să scadă semnificativ pentru ecosistemul companiilor lui Musk. Totuși, atingerea obiectivului final, acela de a procesa 1 milion de unități lunar folosind tehnologia de ultimă oră de 2 nanometri, este privită de experții independenți ca o țintă realistă mai degrabă pentru orizontul anului 2028.
The entire global AI chip industry combined currently produces roughly 20 gigawatts of compute. If Tesla hits this target, the Terafab will outpace the collective output of the entire planet by a factor of 50. The story of the Tesla Terafab begins with a fundamental problem in how the world makes silicon. Right now, semiconductor manufacturing is a fragmented global relay race. A chip might be designed in California, fabricated in Taiwan, and then shipped to Malaysia for packaging and testing. Every single handoff is a potential failure point. Every border crossing introduces weeks of delay. In the race for artificial general intelligence, those weeks are an eternity. Elon addressed this directly during his speech at the launch event, saying, "I can't emphasize enough the importance of being able to make a chip, test it, change the design, do another one, and have that all in a single building. By bringing design, lithography, fabrication, and advanced packaging into one tight, vertically integrated system, Tesla can iterate on hardware as fast as they iterate on software." Right now, Tesla is one of the largest customers for giants like TSMC and Samsung, but as Elon noted, even these titans have a maximum rate at which they're comfortable expanding. Even if Tesla, SpaceX, and xAI commit to purchasing as many chips as they are able to produce. Elon put it straight in his remarks, "We either build the Terafab or we don't have enough chips. We need the chips, so we're gonna build the Terafab." One of the most revealing parts of the Terafab launch event was the clarification of what this factory will actually produce. Unlike conventional chip factories, the Tesla Terafab isn't trying to build everything for everyone. Instead, it will be split into 2 dedicated fabs, each focused on a single, highly optimized chip architecture. The first is Tesla's inference chips like AI-5 and AI-6, which live inside the company's vehicles, as well as the Optimus humanoid robots. These products are all built at very high volume, with Elon estimating that the Cybercab alone will outnumber all of Tesla's vehicles today, and Optimus robots being made in the billions. The second chip is where things get wild, the D3. The D3 is a high-power, radiation-hardened processor designed specifically for the vacuum of space.
Prin Terafab, Elon Musk își dorește să construiască nu doar o fabrică, ci o infrastructură care să susțină totul, de la munca automatizată pe Pământ până la primele colonii de pe Lună și Marte. Pentru mulți, teama de a-și pierde echilibrul la semafor sau de a scăpa motocicleta de pe loc a fost bariera principală în calea libertății pe 2 roți. Însă granița dintre robotică și transportul urban se șterge definitiv. Un startup inovator promite să lanseze producția pentru prima motocicletă electrică din lume, care își va menține singură verticalitatea, transformând condusul într-o experiență sigură chiar și pentru cei care nu au mai urcat niciodată pe o motocicletă. Revoluția pe două roți ar putea să vină din Singapore și poartă numele OMOWAY OMO-X. Această motocicletă nu este doar un vehicul electric obișnuit, ci un veritabil robot pe două roți, care sfidează legile gravitației prin intermediul unei tehnologii împrumutate din industria aerospațială. Secretul stă ascuns într-un sistem complex numit Control Moment Gyroscope, un disc care se rotește cu viteză amețitoare în interiorul șasiului, generând forțe giroscopice capabile să corecteze în milisecunde orice tentativă de înclinare nedorită. Rezultatul este aproape magic. Motociclistul poate sta nemișcat în trafic, fără să atingă asfaltul cu picioarele, iar motocicleta va rămâne perfect verticală, indiferent de vânt sau de denivelările drumului.
This might be one of the most important shifts in motorcycle design in recent years. Because when you look at traditional motorcycles, the biggest limitation has always been stability at low speeds. Below around 10 kilometers per hour, motorcycles become inherently unstable. Riders need to constantly make micro-adjustments to maintain balance. And this is exactly where most beginner mistakes happen. In fact, a large percentage of low-speed motorcycle accidents occur during stopping, turning, or slow maneuvering. So, the question is simple. What if a motorcycle could actively stabilize itself? The OMOWAY Smart Electric Motorcycle is designed to answer that question. Instead of relying purely on rider input, this system integrates electronic stabilization to assist balance in real time. This means the bike is no longer just reacting to movement, it is actively controlling it. At a technical level, this changes the entire interaction between rider and machine, because instead of constantly correcting balance, the rider can focus more on direction and awareness. In urban environments, this becomes even more important. Stop-and-go traffic, tight turns, and unpredictable situations are where traditional motorcycles struggle the most. And this is exactly where a system like this can make a difference. By reducing the need for constant balance corrections, it lowers the cognitive load on the rider, which means less effort, less stress, and potentially higher safety. But this also raises a bigger question. If a motorcycle can stabilize itself, how much control should the rider actually have? Because at some point, this stops being just a motorcycle and starts becoming a smart mobility system. And that's exactly what makes the OMOWAY so interesting. It's not just an evolution of the motorcycle. It's a redefinition of what a motorcycle can be.
Dincolo de acest echilibru hipnotizant, arhitectura OMO-Robot aduce o suită de dotări de siguranță activă care ar putea face gelos orice posesor de mașină premium. Sistemul Halo Pilot monitorizează mediul înconjurător la 360 de grade prin camere și senzori inteligenți, fiind capabil să frâneze de urgență sau să avertizeze motociclistul despre pericolele din unghiul mort. Mai mult, motocicleta învață în permanență, adaptându-și comportamentul pe suprafețele alunecoase prin algoritmi de inteligență artificială. Versatilitatea este un alt punct forte, designul modular permițând transformarea caroseriei dintr-un vehicul zvelt de oraș într-un tourer robust gata de aventură printr-o simplă atașare a unor panouri și genți laterale dedicate. Deși pare desprinsă din filmele science fiction, OMOWAY OMO-X este un proiect cât se poate de palpabil, pregătit să intre în producție de serie în luna mai a acestui an.
Visually, the OMOWAY looks more like a futuristic mobility platform than a traditional motorcycle. The design is minimal, clean, and highly integrated, with a strong focus on aerodynamics and system efficiency. Instead of exposed mechanical components, most of the critical systems are hidden within the body structure. This not only improves airflow, but also gives the bike a more refined and modern appearance. The overall silhouette is compact, but the proportions are carefully balanced to support stability and control. The chassis is designed to accommodate multiple configurations, including urban commuting, longer distance riding, and modular upgrades. This flexibility suggests that the platform is not just a single product, but part of a larger ecosystem. In terms of dimensions, the bike maintains a relatively low center of gravity, which is essential for both balance and handling. Weight distribution is optimized to work together with the self-balancing system, ensuring smoother transitions at low speeds. Performance-wise, early estimates suggest a top speed of around 110 to 120 kilometers per hour, which positions it clearly within the urban and suburban category. Battery capacity is expected to be in the range of 6 to 8 kilowatt hours, supporting a real-world riding range of approximately 150 to 200 kilometers, depending on conditions and riding style. Charging performance is also an important factor. With fast charging support, the battery can go from 20 to 80% in roughly 40 to 60 minutes, making it practical for daily use. What truly separates the OMOWAY from traditional motorcycles is not just its design or balance system, but its integration of intelligent technology. This is not simply a vehicle. It's a connected, sensor-driven mobility platform. At the core of the system is a combination of cameras, radar modules, and ultrasonic sensors, working together to create a real-time understanding of the environment. These sensors continuously scan the surroundings, detecting vehicles, pedestrians, obstacles, and road conditions. The data is processed by an onboard computing unit, which analyzes the situation in real time, often within milliseconds. This enables a range of advanced rider assistance systems. For example, adaptive cruise control allows the motorcycle to automatically adjust speed based on traffic conditions, maintaining a safe following distance. Collision warning systems monitor potential hazards ahead, alerting the rider or even initiating corrective actions when necessary. In more advanced scenarios, the system can support assisted braking, reducing stopping distance in emergency situations.
Poate cel mai surprinzător aspect rămâne prețul de lansare, care se estimează că se va situa în jurul pragului de $4.000, făcând această tehnologie de ultimă oră accesibilă publicului larg. Dragilor, acesta a fost PoliTech de astăzi. Eu sunt Alexandra Marian și vă aștept și săptămâna viitoare.